All right, thanks for attending the very last session, the very last day. I'm super happy to be so many people around here. So let's get going. So my name is Alexis. I'm a group product manager at Unity, working on game server hosting solution. We have a demo kiosk over there, so if you want to check out, please do. And in the room, we have Sam Smith, my partners in crime on that, engineering managers for us. So what are we talking about today? We are talking about clients hosting and server hosting. And I want you to think about those things not like being purely technical decisions or like money decisions, but like, let's say, uh, as being like a result of your game design. Game design is an outcome you want to achieve, and you want like to pick and choose the right solution that can let you achieve your outcomes. So if we go through the basics, and like really the basics, multiplayer is all about the exchange of information between players. I'm shooting you in the face, you're shooting me in my face, and we're walking around the same map. That's exchanging information right here. But also, that means that right now, there is two kinds of multiplayer. There is the one you're playing with your buddies, sitting on your couch, sharing the same gaming devices, and like having using your control, the same controllers. That's what we call like offline and couch multiplayers. But nowadays, when you say multiplayers, people think online, which means across local network, or for instance, over the internet. So, if we look at online specifically, because that's the topic of the day, that's what we do here. It's like you have one host running one session, and you have like a number of like client connecting this session to this host. And if we look at what we have, the two main topology we find, we have what we call the client hosted, that you may know as peer-to-peer, or for instance, peer hosted. And those things are essentially everyone is a client, everyone's a gaming devices, your phone, your console, your workstation, but one of them is being the host. Everyone connect back to this host. So that's essentially what we call peer-to-peer, right? Then we have server hosted. And server hosted, same, topology, but instead of oops, sorry. What's happening? We're losing the screen here. Oh, good. Okay. What I mean by that is like instead of having just client and one of them is the host, what we have here essentially we have one server with far more capable than any gaming device here. So that's what we call server hosted. Okay, but now, Alexis, which one should I pick for my game? Yes, you're right to ask. Well, before I answer the question, let's step back on that. So, again, I want you to think, let me go back so I set the table. I want you to think through like, this is a game decision, a game design decision. What really matters to your game? Why are you doing this? Why are you picking up like peer hosted versus server hosted, for instance? Well, I'm not pretending I have the right solution for you. It's just like some idea how to think about this decision, what really matters to you. So again, if you take like those things, and it can be many other like type of things you can be thinking about. There is like the latency, the connectivity. How fast do I need this multiplayer information to go from point A to point B, and how reliable I need it to be? Or for instance, what's the delay I can afford? Is that a few milliseconds or is that like a couple of seconds? That's one first question. The one is going to be also, do I need my multiplayer session to survive if like one client goes away? Or do I want to rotate my client among these sessions? That's one question. Or for instance, also for ready, do I need my servers to be like my host to be more powerful than my gaming devices? Because if you think of that, a game server can have, let's say, dozens of core, dozens of gig of RAM, right? But on the other hand, one of your game client could be a cell phone. The cell phone is minuscule compared to that. Also, your cell phone is moving across between cellular and Wi-Fi. So you need maybe you want to have your servers being like a fixed point on the internet with like an infinite amount of compute. So that's something you need to think about. And the last one also as well, flicking again, fairness and moderation. Do you need to watch after your players? Do you need to play bad cop, good cop with your players? If yes, maybe you need to find a way to secure that among your game session. That's like only a few, let's say, game. Oh, I think I forgot all the text I had. Anyway, cool. Let's go with that. So, what we mean by that is that also we need to balance that with two other dimensions, which is like one is cost and complexity. And that gives you, in a nutshell, your hosting decisions. If we spend about time on like cost and complexity, cost essentially means like, do you need to support an infrastructure? Do you need to invest into that? And do I need to hire or train staff to maintain this like entire stack you're building? Same on the complexity side. What type of processes and expertise I need to acquire or build? And also what is, let's say, technical footprint do I need to achieve my outcomes? All the things you need to learn to make it work, depending on the solution you choose. So that's the thing, if you start to balancing them together, you can start building like a decision tree. Going back to peer-to-peer versus game servers. Do you need real-time communication? The question might be no. Maybe you can go with an asynchronous solutions. But if the question is yes, then you start considering client-hosted or server-hosted. And we're going to spend time on that. So if you look at asynchronous solutions, because we need to address those as well, think about a chess game when you're playing chess with friends. Do you need that to be real-time? Probably not. You can even play chess over the mail, the regular mail, not like the postal mail. So that means that if, let's say you want to do something which is with asynchronicity that doesn't need to carry over data under a few hundred milliseconds, maybe a lightweight backend with HTTPS services, WebSocket is good enough for you. You don't need more than that. And things like a chess game, co-op escape room game, hidden object game, whatever you have, which with built it, that tolerate, asynchronousness is good for you. But let's say no, I do need real time. I need to know that if I'm shooting Sam in the face, or he shoot me in the face, I need to do that immediately. And I need to know that in a 3D space. I need this information as soon as possible. Okay, now we're talking. That means we need some form netcode, and we need to traverse the internet. Okay, so for that, yes, client hosted and server hosted, obviously. So now I'll spend some time on that. The first one, client hosted, aka peer-to-peer. Many clients, but one of them is the host. Many gaming devices, one of them is the host. What I mean by that? It works really well across most of game genre. You could build amazing game with peer-to-peer. That's totally okay. They are fairly easy to build and operate. You don't have a huge amount of stacks. Again, but you still need to worry about the netcodes. But again, in terms of online services, that's okay-ish. Also, that's usually fairly cheap compared to server hosting. But they come with some caveats. First of all, if your host, which could be a cell phone, goes away or disconnect, the session is gone. No more host. Or you have to implement host migration, which is hard. Also, you're limited to your gaming device's performances, which means, again, a cell phone is very limited. You cannot run a lot of players on that or complex simulations. So you have to be very specific about type of game you want to run. And also, no one prevents anyone to compromise the gaming devices, which means you can get cheating, toxicity, whatever. So it's very hard to control. Unless you go and start securing your customers, your players' gaming devices? I don't think so. If I look at actual solutions for that, we have what we call direct connections, aka night traversal. Again, star topology, client hosted. Everyone connects straight to the other one using the IP address. There is no, and you're using some form special software to traverse different NAT configuration you can find. That's probably the cheapest option you could find. No hosting, none whatsoever. It works really well across local network or someone close to you or with a network close to you. But some NAT configuration cannot be traversed or can be very difficult to traverse. A latency over the internet can be really difficult to troubleshoot because you have no control of what's happening. It can be different layers of NAT. And also, privacy is a big concern. That means all your clients see one other IP. I can reverse look up Sam and know where he lives, and start stalking him. We don't want that. Okay, but we can do something about that. We have something like relay connection. So, what's a relay server? Same idea, star topology, but there is no more direct connection between the client. We have a relay server. That thing means that anyone connects straight into this IP address, which is the same for everyone. They don't see another one. They just see the relay server in the middle that mediates all the traffic between them. But you still are having the same thing. One client is playing host. What does that mean in terms of advantage? Well, you massively simplify and improve the connectivity. Also, you can have great latency if you have the right relay server around the world close to your customers. And privacy is on by default because you don't see the other client IP. You only see the relay server. It does have some cost on hosting because you're running relay server, but also your relay server location can impact latency. Let's say that you're playing in Paris, but the next relay server can connect with in New York while you're taking a hit in terms of connections. So you need to be careful how you set up your relay server across the world. So I think we're good on time. Yeah. Good? Okay. So now we have done sorry. Yeah, okay. If we review again the framework I show you later. Latency connectivity, we have a way to address that, making sure it's going to work well across any device, mostly using relay connection, for instance. But also, for instance, like if you're looking at host persistency or authority, all the things I mentioned before, it's okay, but probably won't be able to like host Fortnite, for instance, for sure. And in terms of fairness and moderation, wow, there is no way to protect your game, like your game there. You're completely at the mercy of like bad actors or like bad players. So also, if you look at cost and complexity, fairly green, not super expensive, not super complex. There is a lot of solution out there. We have one, for instance, our relay servers you can use. It's something easy to set up and to run usually. In terms of like, yeah, so definitely something that works well for, let's say, non-ranked PvP, or right, ranked PvP, co-op game, and small amount of players, because again, you're bound to the gaming device performances. Now, server hosting, that's a big piece of the meal. So that one, there is just one solution, which is the dedicated game server hosting. Again, a beautiful star topology client with our gaming devices connected to a host that just does that, and that usually has crazy amount of horsepower and amazing bandwidth. Wonderful. So what that brings to us? First of all, well, if you dispose enough game servers around the world, close to your customers, you have amazing, reliable, low latency networking. No one has any issue connecting to your game because it's a fixed point over the internet. Also, your game servers are, again, far more resilient. They're not dependent on like cell phone coverage or Wi-Fi. And also they have like much more powerful than any gaming devices out there. So we're talking about like multiple cores and like dozens of gig of RAMs. That things can host many clients at once or can run complex simulation. And yes, because it's a protected host you control, it does enable server authority and anti-cheating. That's something very strong to have, especially if you're doing competitive. But at the same time, it does cost some money. You're running a lot of servers out there, so it can cost you some money. It's also becoming your most critical dependencies day one, which means like if your servers goes down, you don't play. So your competitive game, kaput. Also, if you're becoming a big popular game, you start attracting bad actors. That's where you start to have fun with like DDoS. DDoS is really hard to solve. So you're becoming a target out there on the internet. And finally, you have to learn and control and upgrade a lot of things. You have to learn about CI/CD pipelines, real-time deployment, observability, remote configuration, matchmaking, and so on. That's a lot of things to take on at first. So you have to go get in there, learn those things. So that's all the solution I want to talk to you through. If we look again at my framework I gave you earlier, latency, activity, super fast over the internet. Host persistency, authority, capacities that exceed any gaming devices, check. Fairness, moderation, same. But now if you look at cost and complexity, now that's where you start, that's the trade-off you have. Because yes, you can have infinite capacity, but do you have infinite money? Maybe not. That's why you need to be careful about. And yes, you need to learn a lot of things. So either you're super smart, or you need to start hiring a bunch of people to do that for you. Again, super cool, but hard to find nowadays. So think about that. But also, yeah, some rewards. If you want to build the next Fortnite, competitive FPS, anything, that's the way to go. It's also amazing to host a large number of players on one devices. You cannot do that with your cell phone. You can do that with servers. If you want to do like 64 players, 100, a billion, use game servers. And finally, amazing for complex simulation. If you need to run physics detection, if you want to do other things like that, or like spawn events across the server, you need a lot of RAM and a lot of compute. You need a game server. It also integrates really well in any backend you develop because it's a fixed point over the internet, easy to connect back into matchmaker, economy systems you might have. Okay, we're wrapping up now. So a couple of key takeaways. Again, it's a design decision. What type of game do you want to build? If you want to do competitive FPS, you should look really hard at server hosting. But again, if you want to do something more mellow, which is less intensive, maybe peer-to-peer is fine enough for you. But it's always going to be your game priority, not just like a technical token. Also, consider always match discovery. Or do I want my players to discover one another? That's a hard one to solve as well. If your design does require server hosting, there is no going back. You cannot turn it off. It doesn't work that way. You cannot transition back to peer-to-peer because that's a different game design. But also, if you do server hosting, that's its own rewards. It's a high risk, high reward situation where it does enable very high and long retention. And you can look it up on the internet right now. Go on Steam, check all the top 10 that's been around for 10 years or 15 years. They are mostly using game servers, most of them. And again, it's not something which is completely black and white. You can be either using, for one game mode, game server hosting, or for the other one, you could be using peer-to-peer, and that's fine. Or you could be start developing Relay, and for QA development, you can use peer-to-peer and just use your game server hosting when you're going live or when you're updating a new version and so on. So that's it. Maybe because I need to sell you something. We have game server hosting, we have matchmaker, relay lobby, we have beautiful netcodes. All those things are on demo over there, and we are expert about that. So you have questions, come talk to us. But also, it's not the end of the day. That's just the building foundations. The other one, UGS, Unity Gaming Services. Maybe you're not aware of that, but Unity has an insane ecosystem to build and operate your multiplayer game. We have everything you need to build your multiplayer game, everything to manage your players, things to operate your game at scale, and also how to engage with your players, how to build analytics tools, and so on. And finally, do you need to monetize your mobile games? Yes, we have the right tool for you. That's all the things that we offer today with Unity Gaming Services, or UGS. Come talk to us. And now I'm done, and happy end of the GDC.